this video, we are going to learn some properties of positive integer by using the Euclid division lemma. This type of questions are generally asked for 2 or 3 marks. Okay, so the questions are like this. Show that every positive even number is of the form 2q, where q is any integer, and every positive odd number is of the form 2q plus 1. Now you know that the odd and even number. Okay. Now if you see the 2 and 4, these are even number. That means that are divisible by 2. And what is odd number? In any even number, if you add 1, you will get the odd number. This is one the basic idea. We know this all thing. Now only we want to prove this theoretically. For any integer, if q is 0, again 2 is 0, like that. 2 into 0 will be 0. That is again the even number. 2 into 1, again 2 into 1, 2. Again even number. 2 into 2, again even number 4. Means we want to generalize this type of number. Even number is always of the form 2q and odd number is of form 2q plus 1. Now you know that by Euclid division lemma, any integer a can be written in the form of bq plus r for unique q and r, where restriction on r 0 is less than equal to r and r is strictly less than b. Now what you want here? Here you want 2q plus 1, means let us take b is equal to 2, as whatever you want, according to that we are choosing the b. As we want 2q, means here 2q will be there if b is equal to 2. So consider that b is equal to 2. Now what about r then? If b is equal to 2, for following this condition, r should be strictly less than 2, means what are the possibility of r? R can be 0, as r is less than equal to 0 and r is equal to 1. For that only two possibilities, we have to find the integer. So let us a is equal to 2, as we have taken b is equal to 2, q plus r is 0 for first case. R is equal to 0. Now r is equal to 1. Implies that a is equal to 2q plus 1. Now these are the two integers we have find it out. Now you know that 2q plus 0. Now you know that 2q, if any integer multiplied by the 2 is always even number, and if we add 1 in the even number, it is always of the form odd number, and that only we want to prove. So a is equal to 2q is divisible by 2 for any integer. If you take the 0, 1, 2, 3, every time you will get 2q is equal to even number, and a is equal to 2q plus 1 is odd. This implies that it is even number, and if in even number you add 1, it is always of the form odd number. Hence we prove that every positive even number is always of the form 2q and odd number is always of the form 2q plus 1. Now let us see another example. Show that any positive odd integer is of the form 6q plus 1, 6q plus 3 and 6q plus 5 for some integer q. Here not for every integer, because if you put q is equal to 1, then it will be the 7, but q is equal to 2, again you will get 13, but q is like that, means for some integer q, this is of the odd number. Now we have seen that every positive or even integer is of the form 2q or 4q also, like that. Now what you want to show, that is 6q, means decide b should be equal to 6. According to question we are choosing the b. Then what are the possibility of r? 1, 2, 3, 0, okay, 0, 1, 2, 3, 4 and 5, because r should be strictly less than 6. According to the condition we are choosing the b. So now according to Euclid division lemma, and this step you should write always, okay, bq plus r, where 0 is less than equal to R, strictly less than B. This you always write. And now according to our condition, what are the condition here? B is equal to, let B is equal to 6. So therefore R are the 5 condition. So I am writing for R is equal to 0. What will be the A? A is equal to 6 as B is a 6. 6q plus 0, that is only 6q. Now next, R is equal to 1. A is equal to 6q plus 1. Okay. Now if R is equal to 2, A is equal to 6q plus 2. Only we are putting the values. Okay. Now R is equal to 3. Here A will be 6q plus 3. If R is equal to 4, implies A is equal to 6q plus 4, and R is equal to 5, implies A is equal to 6q plus 5. Now, but what we want to show that odd integers are of the form. Now 6q can be written as 2 into 3q. Is it? Now if any integer, this is sum of the integer as q is some integer, therefore 3q is also some integer. Now any integer multiplied by 2 is always even. Okay. Now this is the 6q, means 6q is even and plus 1, therefore this will be odd. Is it? Only like that you have to write. As 6q is a even, 6q plus 1 is odd. Now this one, this is even number, and again if you are adding 2, it will be again the even number. Or in simplified way you can write 2 take common, here will be 3q plus 1. Now 3q plus 1 is some integer. Okay, some integer into 2 is always even number. Therefore now this is nothing but this odd number. If you can write this 6q plus 3 like 6q plus 2 plus 1. I split it here. It is not expected to write this, but I am explaining you. So directly 6q plus 3 is odd, because this is the even number plus 1 is odd. Now automatically this is also even, and this is going to be odd. Like that you have to explain this question. It is very simple. Just decide what you want to show. If you want to 6q plus 1, means you have to choose B is equal to 6. So what is the B, and now what is about the R? R should be strictly less than 6, means R should not be 6. So what are the possibilities? All the possibilities of R, that is 0, 1, 2, 3, 4 and 5. For all you have to write this integer form, and this is very important. Every time you have to write this and then proceed further. So you will get odd and even number. If this question can be changed, show that any positive even number is of the form 6q plus 2 and 6q plus 4. That time also you have to need to do this all things. Okay, let us see the another example. Now let us see the another example, and this type of square and cube example is asked for the 3 marks. Okay, now here show that square of square, okay, number not only, its square also. Square of any positive integer is either of the form 3m and 3m plus 1. Either this form or this will be, but the square of integer. Now but we can consider by the Euclid division lemma integer, and then we will take the square, and then we will show that this square of that any positive integer is of the form 3m and 3m plus 1. So by Euclid division lemma, what you can write? Now what you want, that only you are going to consider. That is 3m we want. So we are taking B is equal to 3. Okay, so what are the possibility of R? R is equal to 0, 1 or 2. Okay, now but we are going to write plus BQ plus R, and every time you just write out this condition also. Okay, don't forget to write it. B, and here is 0. Okay, now for R is equal to 0, what will be the A? A is equal to 3q plus 0. Okay. Now 3q plus 0, that is only 3q. But you don't want to show that integer is of the form. Means here integer is of the form 3q, but you want to show square of it. So what we will do? Squaring. According to problem we are doing. Okay. So squaring, what you will get? A square. Means square of any integer is equal to 3q square. That is 9q square. Is it? So now but we want to form 3m. So what you can write? 3 into 3q square. I just write down 9 as 3 into 3q. Now this 3q can be denoted by the m. 3q m. Now it is of the form. According to condition we are taking what we want. As we want 3 here, so I have taken out the 3 and therefore, but you have to write for some q, 3q square is equal to m. किसी एक q के लिए, not for every q. This sum is very important because for not every q, always you are not taking m. You are just denoting 3q square equal to m. Okay, for some integer, not for every integer. Now r is equal to 1. I am going to take. Okay, so here we have proved that a square means square of any positive integer is of the form 3m. But we want to show this also. Now r is equal to 1 implies a is equal to 3q plus 1. Okay, you have put the a, r is equal to and b is equal to, you will get. Now but we want the square, therefore squaring again. Squaring on the both side, a square is equal to 3q plus 1 bracket square. Okay, now expand this square. 3q square plus a plus b bracket square. Therefore 2 into ab, that is 3q into 1 plus b square, that is 1 square. Okay, now you will get that 9q square plus 6q plus 1. Now what you want? Here plus 1 you want, here you got the plus 1. Now what about this? You can write it as a 3m. How to write? Take out 3 common. Therefore it will be in bracket from this only. Okay, 3q square plus 2q. Okay, if you take out the common, plus 1. Now this you can denote again by m for sum. This m and this m are notations and for some q. So it is mentioned that for some q. In question also it is given for some integer m, not for m. ऐसा कोई तो भी m होगा जिसके लिए 3q स्क्वायर भी m होगा और 3q स्क्वायर प्लस 2q भी. सम इंटीजर कोई तो भी q ऐसा होगा उसके लिए ये दोनों इक्वल होंगे. This m, why we are writing here 3q square is equal to m and 3q square plus 2q is equal to m, because we are writing here for sum. And this condition should be there when you are writing this all thing. If you are skipping this, you lost your marks. So keep in mind. Now here write down 3m plus 1. Again write the condition for some integer q, 3q square plus 2q is equal to m. That you have to write by the side as a reason. Okay, this is how you can find the solution for the given equation. First of all write this, then this one you will get the 1 mark. After this 1 mark, 1 mark. Okay, for this. Sometimes this question can be asked for the 4 marks or 3 marks. Okay, now hope so you understand, and we will see the cube of the any positive integer in the next